Our tangent graph is what we're going to explore right now. And it looks significantly different than our sinusoidal graphs, than either our sine or cosine type of a graph. So let me point out a couple of the key features for you as we continue to explore this graph through this particular function. As you see, I have this graph listed in blue. Let's look at some of the ideas and the key features. First of all, it's period. As we discovered earlier, the tangent's period is just pi. So the graph repeats itself every pi units beyond this particular case. Its domain are all the values that we can put in to have the function defined. And we see that it's defined everywhere except here at these vertical asymptotes, which on this normal or this particular graph right here, they're multiples of there's two particular places within this graph where they're not defined at, negative pi halves and pi halves. And then again, since it repeats every pi units, you can take multiples of those by pi as well to find out where the domain is restricted at. But just on our base unit we're looking at, we see it's undefined at negative pi halves and pi halves. Its range, what are all the values that we'll get out depending on what value we put in? And so this range looks like the arrow is continuing negative forever and going positive forever. So it looks like we have a range of negative infinity to positive infinity. As we mentioned earlier, it's not defined at some key places, and we call those vertical asymptotes, where it's not defined for particular values of x. So we have a vertical asymptote at minus pi halves and pi halves. Back here on domain, I should say those are values where they're not defined at. So that x does not equal those particular places. X-intercept, where does it cross the x-intercept at? The tangent of 0 is 0. So it crosses right there, and then again it crosses every pi unit distance away from that. So we'll have another graph like this tangent that will just kind of repeat itself with another vertical asymptote. And so right here, it would cross again at pi, or negative pi. And then likewise over here, we have another vertical asymptote, and the graph would look like so. And so if this was 0, here we'd have pi. So the x-intercept is at 0, and then every pi unit distance away from 0. And this is an even or odd function. Does this mean that is it symmetrical with the x-axis, or is it symmetrical with the origin? And as you can see, it looks like this graph is symmetrical with the origin. So we would call this an odd function, meaning that if we had the tangent of some negative x, it would equal the negative of the tangent of x. And so those are some of the definitions and some of the characteristics of our tangent function that we're going to look at, and we're going to begin with in this section.